Hey guys, what's up? So today we're going to be talking about lesson 7.2 again. Miss Caddy already has a wonderful video on lesson 7.2, which is about composite area and what that means and how do we find that. So if you want to go back to her video, I'm going to put a link on this side over here. I'm going to put a link up here to take you to her video so you can watch that one, because she pretty much explained everything that there is to know about composite area, everything that you need to know. Um, there are a couple of things that she didn't really go over, which is fine because you're expected to know that anyway from our previous video on area and perimeter, which again, I'm going to link right now on this side over here. Where's my hand? Right here. So I'm going to link that video here so that you can go watch that one in case you need the formulas for area and perimeter again. What I'm going to do today is I'm kind of going to do the same thing Miss Caddy did, but I'm going to break it down a little bit more. So step by step, so that you know exactly what to do, what are you supposed to be looking for, and what you can do to find the composite area, whether you need to add them or subtract them. I'm going to go through that real carefully. I have two examples that neither of us have done already, two more examples, and hopefully those will help you out. So let's get started on that. All right, so here we go. Lesson 7.2, composite area. And this is a continuation. It isn't anything brand new. Like I said, Miss Caddy already has a beautiful video out, but this is for more like in-depth analysis on how to do composite area for those that are still having some trouble. So our objective is to explain how to find the area of a figure that involves adding and subtracting area of multiple shapes. So when we talk about composite area, we're talking about a shape that is made up of simpler shapes. So let's take a look at some examples of what we mean by composite area. So composite area refers to an amount of area taken by combining the area of multiple shapes or removing the area of multiple shapes. That's what we mean by composite area. So if I take a look at the example on the left here with this red square and the red triangle. Now I remember how to find the area of a square and a triangle from the last video from using my area formulas. So if I combine these two shapes, then I get like basically an arrow shape or a house shape. But to find the total area of this shape now, since I already know the area of the triangle and I know the area of the square, then all I have to do is add them. So this is what we mean by additive area. Additive because we add them. Now take a look at the example on the right hand side. I have a gray triangle and a white square. Now, if I put this square inside the triangle, since the background's already white, I basically am getting rid of all this area here. So instead of having all of that in my gray triangle, now I'm cutting out this square-shaped piece from that area, which means that instead of adding like I did with the red shapes on the left side, I'm going to be subtracting area now. And so this is what we mean by subtractive area, because now I have the area of the triangle, and I can put a tri for area of triangle, and I'm subtracting the area of the square, so minus a square, area of the square. Whereas here, I was adding them. So I had area of the triangle plus the area of the square. So let's take a look at two examples now. I'm going to break it down bit by bit, piece by piece, so that we see what we're going to be doing to find each area. Take a look at example number 1. So we need to find the area of the shaded area. Now, the shaded area is only this piece, and it's already shaded in gray, so I'm not going to mark it anymore. But we haven't seen any shape like this, and there is no formula for a shape like this. But what I do notice, and I'm going to outline those with my highlighter, what I do notice is that I have several shapes here. I have a triangle right here. I have another triangle over here. And I have the trapezoid, which I'll outline in green here. Now notice that the trapezoid is including all of this. So that red triangle that I highlighted is part of this trapezoid. But since the triangle is white, that means that I'm taking out the area from the triangle, which is this part here. I'm taking this area and I'm eliminating it from the trapezoid. And that's what's going to leave me with this part, the gray part right here. So what I'm doing, and I don't even need this triangle for anything. You see how I'm not using this triangle at all. So I don't even need this one. So in fact, what I'm going to do is I'm going to erase my highlighting from this triangle since I don't even need it. So let's clean up the picture a little bit because right now it's really messy. But we've established that we have two shapes here. We have the red triangle, we have the green trapezoid, and we also have the shaded area that appears when you take the area of the triangle away from the area of the trapezoid. So let's clean this picture up so we got a better view. Now again, I'm going to highlight my trapezoid, which is like this, and I'm going to highlight my triangle. Now that I have the trapezoid and triangle highlighted, these are the two shapes that I'm going to be working with. So I'm going to set up a section over here on my work for the trapezoid. Now, because all of this is involving area, I need to know how to find the area of a trapezoid. And if you remember from our last video, the formula for area of a trapezoid is base 1 plus base 2 times height divided by 2. Now, I'm not even going to worry about the triangle right now. Forget about the triangle. I want to concentrate only on finding the area of the trapezoid, which means I need to find what is my B1, what's my B2, and what's my height. So I'm going to label those down here, B1, B2, and my height. And I'm going to be finding each of those. So if I go back to my picture, my diagram here, I remember from our last video that the bases are always perpendicular to the height. Perpendicular, meaning that I have that right angle. But if I look here, here's in right angle. Which means that this line right here, this 14, is perpendicular to this line and perpendicular to this line. Now, the reason why they have the rectangle out, that happens for various reasons. Either they're trying to confuse you, or there's no space over here for that square, for that right angle. And if you see down here, if I put that square here, it's going to be confusing a little bit. So that's why they put it over here. But always when I have that perpendicular, that right angle, then I know that those lines connected are always going to be perpendicular. So really, My base 1 is here, and my base 2 is here, and this is going to be my height. Now the 12 meters here refers to this part, 30 meters is this part, and my height is this. So I know that my B1 is 12 meters, my B2 is 30 meters, and my height is 14 meters. So now that I know those, I have everything I need to find the area of my trapezoid. So let's take our formula. Let's substitute the numbers that I have into my formula. So my B1 that I found was 12. So let's plug that in. I have 12. My B2 is 30. So let's plug that in. Then I close my parentheses just like I have it in my formula. Then I have H. I know that my height is 14. So I'm going to put 14 in parentheses so that I know I have to multiply those. And then this is all divided by 2. So now all I have to do is go to my calculator and plug that in. So let's start with the parentheses. 12 plus 30. Close that parentheses. Open another one for the 14. And me personally, I like to do this one step at a time. If I don't have the school's calculator that lets you put it all in at once, I'm going to do this step by step. So I'm going to do the top first. 12 plus 30 times 14. Press enter. That's 588. Now I still need to divide by 2. So 588 divided by 2 gives me 294. So the area of the trapezoid, now write it over here on the side, area of my trapezoid is equal to 294. 294. And that is meters squared. So 294 meters squared. Now that's only for the trapezoid, but remember, now that I have the area of the trapezoid, I need to subtract the area of the triangle. So I'm going to set up another section down here. I'm going to label that triangle. And my formula for area of a triangle, A equals base times height divided by 2. Now remember, just because it still has base and height, just because it still has B and H, doesn't mean that these are going to be the same numbers from this formula. So like our height up here was 14. That doesn't mean that the height here is also 14. I need to be careful and look at my shape and verify that the height is still 14. So if I look at my triangle, I know the height needs to be here. Now, is this line the same as 14? Does it go all the way from the right to the left? No, because there's this part that's 5 meters, which means that this is not 14. So I need to find out what is this length right here. Now I know that if the total length from side to side is 14 and this part is 5, then I can subtract 14 minus 5, which gives me 9. Which means that this height for the triangle is 9 meters. So I'm going to put a B here for base, which I'm going to find right now. And I'm going to put an H for height, which I now know that is 9 meters. Now the base of the triangle, though, if I look at the base, it starts from up here, goes all the way to down here. So the base of this triangle is 30 meters. So that base will still be 30 meters. But not because it was one of the bases up here, but because I verified that from this point to this point is still 30 meters. So now that I have the base and height for my triangle, let's find that area. So A equals base 30, and I'm going to put that in parentheses so that I know I'm going to multiply, times 9. Then this divided by 2. And again, I'm going to find the area of the triangle by plugging this into the calculator now. So if I go to my calculator, I have 30 times 9. That's 270. So 270 divided by 2 is 135. And that is also meters squared. So now that I have the two areas, this is not yet over. The last thing that I need to do, remember, my goal is to find the shaded area here, which means I'm going to take the area of the trapezoid and subtract from it the area of the triangle. So I'm going to set it up over here. I'm going to do this in purple so it's different. So the area of my trapezoid was 294. The area of the triangle was 135. So if I subtract these, let me go to my calculator. 294 minus 135 gives me 159. So my final answer now is 159 meters squared. Remember, it's kind of a lot of steps, sure. But these are things that you should know how to do by now. You know how to find the area of a trapezoid. You know how to do this. You know how to find the area of a triangle. You know how to do that because you watched our videos from Monday, right? So you should know how to do that. The only new thing that we're doing here is once I know those areas, I'm going to be subtracting them. Subtracting because I'm looking for the shaded area. I'm only looking for this part right here. But to find that part, I need to find the big area and take away, subtract, eliminate the white area from here. So you need to be able to recognize the shapes so you know which formulas to use, which areas to find, and then subtract them. And remember, you have questions, make sure that you ask one of us. Let's take a look at an example of where we have to add the area this time. First, let's read the instruction. Find the total area of the shape. So now you see that in our shape, there is no gray area here. So we're not finding the area of a shaded part like we did over here. Instead, we're going to be finding the area of all of these pieces and combining them, adding them to find the total area here. So let's take our highlighter and let's identify first the shapes that I have here. So first off, I noticed right away that I have a rectangle here. So I'm going to highlight that. The next thing that I see is that there is a triangle here. So I'm going to highlight that. Finally, I also see a semicircle. So I'm going to highlight that in blue. Because I'm adding all of these, I'm going to be adding 3 areas together total. So why don't we start with the easiest one? Let's start by finding the area of the rectangle that we have. So let me create a section up here for the rectangle. And I remember that the area of a rectangle is simply base times height. So I'm going to identify the base and the height. Now remember that in a rectangle, it doesn't matter which one is the base and the height, as long as they are perpendicular to each other. So I see one of them on the rectangle is 9. So I'm going to call that my base. So I have 9 feet for the base. Now for the height, Notice that I am looking for this piece. That's going to be the height of my rectangle. But I don't have that. All I know is that the entire length from the top of the rectangle to the bottom of the semicircle is 26 feet. So I need to break this apart then. I need to separate this so that I have only the rectangle, only the part of the rectangle, which means I'm going to have to work with the semicircle a little bit. So what can we do here? Well, let's start by finding this out. If I know that for the semicircle, I'm going to have a radius, right? So I need to find what is this radius. But I see that the semicircle starts here, which corresponds to this part here, this starting point. And coincidentally, it goes from that point to the edge of my semicircle, and I know that that's 9 feet, which means that this should also be 9 feet, which means that the radius of my semicircle is 9 feet. Now, knowing the radius, I know the distance from any point on this semicircle to the center, because that's what the radius means. So I know that this has to be 9 feet as well. Now, if this is 9 feet, means that this distance is 9 feet. Which means that if I subtract 26 minus 9, then I would find the height of my rectangle. So let's do that. 26 minus 9 is 17. So my height for the rectangle is 17 feet. I'm going to write that up here. 17 feet. Now I'm going to find the area. So I'm going to plug the numbers into my formula. Base is 9. So I'm going to put that in parentheses so that I know I'm going to multiply it. And the height is 17. If I plug this into the calculator, 9 times 17, 153. So my area for the rectangle, 153 feet squared, or square feet. So that takes care of the rectangle. Let's do the semicircle next, since I already know the radius now. So I'm going to write a section for semicircle. And I know the area of a semicircle is half the area of a circle. Area of a circle is pi times r squared. And since I'm only doing half, I divide it by 2. So the only thing that I need here to plug in is the radius. So I'm going to put r equals. Now, I already know the radius since I needed it to find the area of the rectangle. I know the radius is 9. So the radius r is 9 feet. So now I'm going to plug that radius into my area formula. So I have pi parentheses 9 squared divided by 2. And again, I'm going to go to my calculator. And this one does have the pi button. So pi parentheses 9 and then squared. I have a button for that here too. By the way, if you want to know which calculator I'm using, go to Desmos.com and click on scientific calculator. You'll see it as soon as the website pops up. There's also a link to it on our assignment page. So make sure that when you look at that assignment, you see the Desmo in blue tech, click on it, it takes you to this calculator. So now I'm going to plug that in. I'm going to press enter here. I get 254.4 whatever, but I'm dividing this by 2. So now divided. But I need to divide this by 2. So I'm going to press answer here. That's going to pop that in. And then divided by 2. 127.23. I'm going to round to the nearest hundredth here. So 127. Let me get that again. 0.23. And that is also feet squared. So now I have the area for the semicircle. So I've got the area for the rectangle. I've got the area for the semicircle. The only thing I have left is the area of the triangle. Let's make a section here for triangle. And remember, we need to identify the base and the height because the area for the formula for area here, is base times height divided by 2. So I need to find my base and I need to find my height. Now I can see that right here, I have a 90-degree angle. So these two sides are perpendicular, which means one of them is my base, the other one is my height. So I'm going to let the bottom side be my base since I'm used to the base being on the bottom. And this must be 9 feet as well, because this is also part of the semicircle. And it goes from the center of the semicircle to the edge. So this is also the radius of the semicircle, which is 9 feet. So now I know what my base is. I know this is 9 feet. Now I need to find the height. But again, the height is this piece right here, but I don't know that. So I need to figure it out. I know though that this section right here is 7 feet. And remember, we were looking for the height of the rectangle that ended up being 17, which means that if I subtract this piece from the total, then I can find the height of the triangle. So 17 minus 7, I'm going to write that over here. 17 minus 7 is 10. So the height of my triangle is 10 feet. So for height, I'm going to put 10 feet. Now I know my numbers. I know what I'm going to plug into my formula. So base is 9. I'll put that in parentheses so that I know I'm multiplying. Times height, which is 10, divided by 2. Now 9 times 10 is 90. 90 divided by 2 gives me 45. So the area of my triangle is 45 feet squared. Now that I have all three of my areas, I got the area of the triangle, I got the area of the rectangle, and I've got the area of the semicircle. So because I'm finding the total area, I'm finding the entire area here, all of this. I need to add all of my areas together. So I'm going to write 153 plus 127.23 plus 45. If I add all those together, I'm going to go to my calculator. 153 plus 127.23 plus 45. That gives me 325.23. So 325.23. And that is feet squared. And so that is my composite area for this figure. So that's it, guys. Like I said, I'm only doing the 2 examples because you also have Miss Caddy's examples from her video. But hopefully this showed you a little more step-by-step process. Remember, doesn't matter whether I'm finding a total area by adding them or if I'm finding a shaded area and subtracting them. We need to start by identifying what shapes our figure is made from. And knowing the shapes that I have, then I'm finding the area of each one individually. So that once I have their areas, then I can combine them to get a total area, or I can subtract them to get a shaded area. So hopefully this video helped clear up any confusions. If you have questions, make sure that you ask me or ask Miss Caddy. Go into your Google Classroom or text us on Remind. Text your teacher, whether that's Miss Flores, Mr. Cortez, Coach Humphreys, whoever. Make sure you ask us, guys, because we are here to help you. We want the best for you. All right? So have a good day. Remember, check out the other videos that I mentioned. Like, subscribe, share, and I'll see you guys next time.